Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will study about what is homomorphism and what is endomorphism and kernel of phi in group theory. Let's start. Homomorphism. Let a group G and H, G with operator dot and H with operator steric be two groups. A mapping phi from G to H is said to be homomorphism if the phi of x dot y is equal to phi of x dot phi of y. Actually, in homomorphism, the operator is preserved. You can see that G is with operator dot and mapping is from G, so domain is G. So here we see that the operator is dot, but H has operator steric and H is range. So here we see that here is operator steric. So operator is preserved in this type of mapping, which is called homomorphism. And for x comma y belong to G, the range of phi in H is called homomorphic image of phi. So as I told that H is range, so range of phi is the homomorphic image of phi. Endomorphism, these are two different groups, but if G star is a group, the homomorphism phi to G is called endomorphism. The mapping is between same sets or same groups, then it is called endomorphism. Let's understand homomorphism by an example. Let R with addition operator and R with dot operator, multiplication operator, be two groups, and phi is the mapping from R to R prime or R dash. Be the mapping defined as this is the function on which we apply the mapping. Phi of x is equal to e raised to power x, where x belongs to real numbers, and the show that the phi is homomorphism. Let's start as the domain is with respect to we are taking addition. So x comma y belongs to R, then phi x plus y, because here the operator is addition, will be equal to e raised to power x plus y, and which is also equal to a raised to power x dot e raised to power y by operating power rule, by applying power rule, and we know that e raised to power x is equal to phi of x. So similarly, e raised to power y will be equal to phi of y. We can see that this is like addition by addition operator, and this look like with multiplication operator. So phi is homomorphic. So phi is homomorphism. Let's see what is kernel of phi. What is kernel of phi? Let G dot G with operator dot or multiplication or any other operator, and H be with operator steric be two groups, and let phi is a mapping from G to H be the homomorphism of group. The set of those elements of G which are mapped on the identity of H is called kernel of phi and is denoted by kernel of phi. Kernel of phi is equal to k raised to belongs to G, and phi of k is equal to E. The elements of G, those map with the identity element of H, are called kernel of phi. For example, we have a function y is equal to x square. So here minus 1 and 1, these both belongs to g, and when we take square, when we give this minus 1 value to x square, so minus 1 square is equal to plus 1, and we know that 1, for example, we say that 1 is the identity element of g, so when minus 1 we take square, it gives us 1, and similarly when we give this value, the other value plus 1 to x square as domain, we again get plus 1. So 1 is also identity of h. This shows that these two elements map on identity. So these two elements of G make the kernel of phi. I hope you understood. If any query, you may comment me. Thank you so much.